Hi everyone, my name is Hannah. Welcome to today's video. In this video, we are going to go over the 1990 AIME number 15. I have pasted the problem here in the upper left corner. Take a few seconds to read over the problem and perhaps think of how you might approach it. Pause the video if needed. I hope you're ready to watch the solution. So the first thing we notice is that each given equation and the final expression that we want to find is in the form a times x to the power plus b times y to the same power, and then the four given are each equal to a certain constant. So a thing we can notice here is that to get from ax plus by, or just a times x to the power plus b times y to the power to the next power, where the exponents are one more than the previous one, what we need to do is we need to multiply by x plus y and then subtract a few multiples of x squared times y squared, x squared times y, or y squared times x, or something involving x, y. So something we need to experiment with is, for example, ax plus by ax plus by times x plus y is equal to ax squared plus by squared plus xy times a plus b. So this is our first relationship between the givens and then x plus y and xy. Similarly, we also have ax squared plus by squared times x plus y is equal to ax cubed plus by cubed plus xy times ax plus by. And then let's write another one, which is ax cubed plus by cubed times x plus y is equal to ax to the fourth plus by to the fourth plus xy times ax squared plus by squared. So note that each of these, you can get these by just experimenting, and the motivation for this step is that you want to get from the first expression, for example, we want to get from this to this, and then you think of multiplying by x plus y because each of these terms is x raised by 1 power and y raised by 1 power. Take a minute to screenshot this or whatever, because I think I need to clear this because I do not have enough space to write the next steps. So because we see this important relationship, a thing we can do is we set big A equal to x plus y and big B equal to x times y. So this step is not necessary because you could write just x plus y and x times y, but it really makes it a lot easier to see patterns, and also you don't have to write as many expressions repeatedly. So I think I need to rewrite two equations from previously that are important, which is the ax squared plus by squared times x plus y, and then the cube version. And the reason I don't need the ax plus by times x plus y is because that one involves a plus b, and a plus b is not something that you're given in the problem. But everything here is in terms of big A and big B, because, well, you shall see that you can substitute all of your given values to get these expressions in terms of big A and big B. And a goal here is to solve for big A and big B because we suspect that we can express ax to the fifth plus by to the fifth in terms of big A and big B and our previous equations. So now, because ax squared plus by squared is 7 by given, so we have 7 times big A is equal to 16 plus 3 times big B, and then this is from the first equation, and from the second equation we have 16 times big A is equal to 42 plus 7 times big B. So now with these equations, we will solve for A and B, which I am sure you know how to do. So let me move this down here. So 16A equals 42 plus 7B, because this makes it easier to solve. So let me erase this real quick. So now we have this system of equations, and this becomes, let's multiply both equations by 16 and 7 respectively to cancel out A. So we have 112A is equal to 256 plus 48B. And then here 112A is equal to 7 times 42, which is 294 plus 49B. And then subtracting the first equation from the second gives B plus 38 is equal to 0, so B is equal to negative 38. And then plugging this into our original equation, well, we could plug it into this, but it's much easier to plug it into that one. So we have 7A is equal to 16 plus 3 times negative 38, which is equal to negative 98. So A is equal to negative 14. So let me erase everything on the bottom because we don't need these right now. Let me just clear the drawings, but we remember that A is equal to negative 14 and B is equal to negative 38, where A is x plus y and B is x times y. So now to find little a times x to the fifth plus little b times y to the fifth, we remember that in our previous equations we always had it in the form a times x to a certain power, which we will fill in a second, plus b times y to the same power times x plus y is equal to a times x to this power plus 1, and then plus b times y to that power plus 1, and then plus xy times a times x to this minus 1 plus b times y to this minus 1. So of course we could plug it in any case because everything else is given. I mean, you could plug it in, like we could let ax to the fifth plus by to the fifth be this or this or this, but to make it easiest, we put it here. So then based on our previous, this would be 4. These exponents would both be 4, and then these would both be 3. So now we plug in our givens to get 42 times negative 14 is equal to our desired expression plus negative 38 times 16. So now let me move up here. So solving gives a times x to the fifth plus b times y to the fifth is equal to 42 times negative 14 plus 38 times 16, which is equal to 20, and 20 is our final answer. Of course, since this is the AIME, we would write our answer as 0, 2, 0, but that doesn't really matter. The actual answer is 20, and that is our solution. So before I end this video, I just want to quickly say a few important things that you need to notice in this problem were that x plus y and xy were our key expressions, because solving for those wound up solving for the actual expression without needing to find a, b, x, and y. Because in some situations when you have complicated expressions in terms of a, b, x, and y, you don't want to solve for the actual variables because that is much more work than needed, and even in some cases, you can't even solve for those, but you can solve for expressions in terms of the variables and then solve for our final result in terms of the given. And another important thing that we would notice is this expression, but generalized. So this expression generalized, let me just clear all my results, but a general expression would be a times x to the nth plus b times y to the nth times x plus y is equal to a times x to the n plus 1 plus b times y to the n plus 1 plus xy times a times x to the n minus 1 plus b times y to the n minus 1. Because here we have everything that we need to solve for, because x plus y and xy were given, and then these two would be given, and then we are solving for this. So in my final expression that I just erased, with the left-hand side being ax to the fourth and so on, n was 4, and then this circled expression was our desired expression. So yeah, in general, in these types of problems, some tips are just to identify what are the key expressions that if you solve for them, you can solve for the desired expression, sometimes without solving for the actual variables. And again, in a lot of these algebraic manipulation problems, when the final result is not directly the variables and instead is just an expression in terms of the variables, you don't always have to solve for the variables themselves. So yeah, I hope you learned something from this, and I hope my solution made sense. Thank you for watching.